Hello YouTube. So in my previous video I talked about these little boards, or rather this LED specifically, but not really the board. So let me talk about that for a second. Alright, so this little solder pad right here is your ground. So this little board can handle up about 90 volts in, and we can drop that down to about 6 volts out. So this is a buck converter with an LED on it. And over here we have high and low, two LEDs, or two diodes rather, and a resistor. So essentially what's happening here is we're creating a voltage divider between here and here that then tell this little guy here to output more or less voltage, and that's your high and low output. And just by applying a voltage here or here, we're basically driving the LED harder or less hard. But still, it's running at about 6 volts, 6.1 volts at its maximum. I don't know what the low beam setting is. I've never bothered to measure it. Anyway, if you doubled up these diodes, doubled up this MOSFET, doubled up that diode, doubled up that capacitor, and doubled up, well, you'd need a bigger 330 microhenry inductor, not double it up. Then this thing could probably handle, say, like 4 amps, which is still kind of low-ish for a legit XHP 70.2, but you could probably drive, one reasonably well. As is, this little board, if it can handle 2 amps at 6 volts, that would be a lot. Otherwise, it's just not going to handle it. It's going to burn out. Also, and this is typical Chinese stuff. It's built to the minimum level they possibly can get away with, and I have to tell you that these LEDs, 2 amps at 6.5 volts is their absolute dead maximum limits, and that is 13 watts, and yet the lights, as they're sold on eBay or out of China on AliExpress, are said to be 18-watt lights. No. No. The physical facts are the LED might be able to do 13 watts, and really it will only do about 12 watts. So it's a 12-watt light, not an 18-watt. They lied already, just in the wattage alone. This is how China does things. And then the components on here, I guarantee you, the best you'll ever get out of this thing is 2 amps at 6 volts. So again, 12 watts. There's no 18 watts here anywhere. And then they do this kind of shit too. It's on aluminum, not copper. Anyway, enough of that. This thing here, I use all copper boards because, well, it conducts heat so much better. I don't care about the little bit extra cost. That's not relevant to me. All right, next thing I want to talk about is, you've already know the story about this in the last video. This LED is burned out. I ran it at 12 volts. It came off of the aluminum block I had it on, so it overheated and cooked. Otherwise, it would have ran for hours and hours and hours at 12 volts, which this guy, at 6.5 volts runs for like less than a minute and dies. All right, so I want to talk about Castle Creation BECs, specifically because this is a super duper good choice for a driver for that LED. So there she is. All right, so on a typical EV that I would have some involvement in, I will always make sure that there is a DC to DC converter. So if your battery pack is 48 volts, 66 volts, 82 volts, 120 volts, I don't care. Get a DC to DC converter that will step that down. It's basically a buck converter inside there to 12 volts. And then this guy works super well at 12 volts. And as you can see, it can handle up to 58.8 volts max. These Castle Creations BEC 2.0s, I specifically get the 14 amp versions. They're about 35 to 40 bucks a piece. They're not cheap, but they are very good. And they make a super good driver for the XHP 70.2. These are a very, very good matched set. So anyway, the lower the voltage you run them at, the more amps you get. Because it's total wattage that you're really dealing with here. So at 12 volts, I can, with it exactly like this, I can probably run this about 10 amps, and it'll do fine. But truthfully, what I do is I cut off the heat shrink, I remove this little tiny heat sink off the MOSFETs, and then I replace that with a piece of aluminum that's thicker, and I wrap it around the board, and cover the inductor too. And then I put thermal glue on top of here and on top of the MOSFETs. So I've basically doubled the amount of heat sinking total I get, and then I'm also cooling the inductor, which does get warm. So then at that point, that 14 amp peak becomes more like my 14 amp continuous. Because it's not like the components on here can't handle it, it's just that there's not enough heat transfer to the air. So increase the heat transfer to the air, and then it can handle a lot more current continuously. All right, so there is a little USB adapter that you buy extra for these things. It's and a Windows app called Castle Link, and you can find them both on eBay for like, well, you can find the Castle Link for like $14 on eBay, and then you just go to Castle Creations website and download the app. Anyway, that connector, you plug that into the Castle Link USB adapter, and then you can program these things for whatever output voltage, 4.75 volts to 12 volts. So that voltage range right there is perfect for that 6 volt starboard. So by virtue of the fact that I've done this, I don't know how many times, a bunch, I just don't even bother, fiddling with 6 volts. I just go straight to like 7.4 volts. And I just let the LED run for a while there, and I'm measuring the temperature of the host to see what it gets up to. And I'm basically looking to see that I stay under, say, like 120 degrees Fahrenheit, which is hot. It's pretty damn hot. That's a Phoenix summer. Phoenix, Arizona summer. That's it. The LED's got to be able to survive a Phoenix, Arizona summer and just run there. And as long as I'm staying at 120 degrees Fahrenheit, I'm happy. And then, I go back into the Castle Link app and I bump this up a little bit higher. Usually what I find is that these LEDs on the typical Chinese hosts that I use will run just fine at about 7.6 volts and not get over 120 degrees Fahrenheit in still air. No moving air to pull heat away. Just sitting there in dead air, and they'll sit at about 120 degrees Fahrenheit, Phoenix, Arizona summer, and live and do just fine for hours. So anyway, they take the heat, and this little Castle Creations BEC is the answer to those my questions as far as a driver. Super reliable, adjustable voltage output, works super duper well, and they are kind of expensive, $35 to $40, but hey, the thing is really small. I mean, look at this thing. It's like the size of the end of my finger. It's a little tiny bugger. And it can handle 14 amps and be adjustable and, be this super compact thing. Yeah. You don't want to put these inside your LED host, most likely, because they'll get too hot. Because, the LED, that guy is making a lot of heat. So you don't want to do that to the Castle BEC. You want to put that someplace where it can, radiate heat itself. So invariably, like for EVs, this will be outside of my LED host, and they'll just tuck it into some empty hole or whatever to get it out of the way. But, Castle BECs. This one specifically, great little device. Works super well. I would strongly recommend that anybody who wants to mess with 70.2 LEDs, on 6 volt starboards, get the Castle BEC. It makes a great LED driver. All right, I think I have one other thing to show you, and that is it. And here she is. I'm on camera. Focus. Yes, I know, you're super close. So this is thermal glue. It's specifically HY910, and it's by, how do you say that? Houndzie, I don't know. I don't speak Chinese. But pretty good thermal paste. Or thermal glue, rather, not thermal paste. So it has all the ingredients of your thermal paste, your white high zinc content, thermal paste, but it's also got a silicone glue in it. It's not as good as thermal paste as far as heat transfer is concerned, but it's good enough. And also it cures into kind of a crumbly, rubbery material because the binding agent is silicone, which is also a reasonably good heat transfer agent. Not as good as the zinc is, which is what makes it white. But anyway, HY910 from these guys, Houndzie, however you say that, HY910, pretty good stuff. I use this stuff extensively. I get the 75 gram tubes. because that's the best price point. These ones I bought, I just bought 3 tubes of this on Amazon, and they were $9 a piece. I use this stuff a lot. Obviously, I use it for mounting LEDs. So, you know, this little starboard is much smaller than the surface area inside the host that's going to get mounted in. I don't want the starboard moving around like it would with thermal paste. I want it to be stuck where I put it and not move again. So this is the answer to my question. I glue it down rather than paste it down, and then it doesn't move. And honestly, I mash the starboard down really hard to get all the little air pockets and things like that out, and then just leave a really thin layer of thermal glue between the LED starboard and the host body. So it's not doing anything other than, you know, bonding basically and filling some little tiny gaps. So I'm not worried about the fact that it's not as good of a heat conductor as some of the better thermal pastes are. It's good enough. That's the important detail. Also, I use this stuff for putting hulls in motors that I rewind, or, you know, I've got bad hulls, I need to replace them. So it works super well for that. And again, the stuff is kind of a semi-rubbery, crumbly material when it hardens. So you can pick it back out again with like a spooger or your fingernail, or, you know, a little pocket screwdriver or something like that, and it'll come back out. So if you need to pull the part back out again, or you need to pull up the starboard, well, it'll come back up again. It's just that on its own, it's probably not going to come loose. I also use this stuff when I am making a battery pack. Like I'm about to make a battery pack out of a bunch of 21700 cells for about 30 amp hours total at 82 volts. And I will put this between the cells to hold the cells together. And again, you know, it crumbles back off again with relative ease, so taking things back apart again later is really not a huge problem. And yet it holds stuff well enough so that they don't come apart on their own. So, yeah. HY910. It's not very expensive, and it's good stuff. I use it all the time. I don't use thermal paste anymore once I discovered that. Well, I think that's everything I want to show you in this video. So, folks, this is De-bodgery saying, hey, stay away from that damn SARS virus, you know, SARS-CoV-2. Don't let your body get sick with COVID-19. You know, that's the disease in the human body that is created by the SARS-2 virus. And be nice to each other. Don't be assholes. You know, treat people with respect. Don't abuse people. You know, do nice things for people rather than be harsh assholes to others. You know, when you're someplace and you can take advantage of them, choose not to. Choose not to. Make the world a better place rather than a worse place. It's already shitty. We already have wars. We already have dickhead politicians like Biden and Trump and everybody else around the world that the same way. We already have all that shit. Why add to it by making the world a worse place? Do your part to make the world a better place. You know, be nice to each other. You know, when you have the opportunity to steal, choose not to. When you have the opportunity to abuse somebody, choose not to. When you have the opportunity to get away with something that you know is shitty, choose not to. Be nice instead of being bad. So, hey, this is De-bodgery saying, hey, folks, take care, be good, bye.